So in this video, we're going to look at what we call special right triangles. Now, if we have a right triangle, two things should come to mind. Pythagorean theorem, which relates the three sides, specifically in a right triangle, and SOHCAHTOA, which relates angles against sides, specifically in a right triangle. But if we know very specific angles in a right triangle, mainly a 45 degree angle with a 90 degree angle, what we'll call 45, 45, 90, or if we have a 30 degree and a 60 degree angle with our 90 degree angle, then these are the two special instances where we can actually be more specific in how we relate these sides against these particular angles. So before we go actually solving for certain side lengths and things like that, we need to justify how the sides kind of match up. So if we had a 45, 45, 90 triangle, like this one, then we don't really know much here, but we do know that whatever this side length is, I'll call it x, since this angle, 45, makes this side, since this angle makes this side, and this angle is the same, it makes this side, then that means he must also be length x. And thinking about Pythagorean theorem, usually we let the hypotenuse be c. So in the Pythagorean theorem, we know that c squared would be equal to a squared and plus b squared, which in this case would just be x squared and x squared. Okay. So what we're going to do is we're going to let one of the legs, right, the legs are the two sides that aren't the hypotenuse, we're just going to let him be x. And then we can justify what the hypotenuse would be in that instance. So we can actually add these two together. So we can say c squared is 2x squared. But we don't want c squared, we just want the length of the hypotenuse c. So if we square root both sides, then we know that c will be equal to the square root of 2 times the square root of x squared. But the square root of x squared is just x. So we could say that this is, I'll just put the x in the front, x times the square root of 2. So the hypotenuse is x times the square root of 2, meaning whatever the leg is, we'll take that leg length and multiply it by the square root of 2. So we're not going to think of this in terms of x's because x is any sort of unknown. So it would be more logical to think of this by relating the legs and the hypotenuse together. So when we look at these, as we move along, I'm going to say that the hypotenuse is equal to the leg length times the square root of 2. That way we're not forcing x to be a very particular side because x can be whichever length we have or designate. Okay? So let's look at a few examples and try to make sense of this. So we are given a right triangle. Since this angle is 45, we know that this is also 45. So we have our 45, 45, 90 triangle. So we can relate these legs and hypotenuse against one another. We know that since this leg is made from 45, this other leg length should also be the same because it's made from a 45 degree angle. So the two legs, again, like we said, are the same length. So we know that x in this instance is 8. And we found out that the hypotenuse is equal to the leg length times square root of 2. So we can say that the hypotenuse, I'm just going to actually write this out. This will help us as things get more complicated. The hypotenuse is equal to the leg length times square root of 2. In this case, the hypotenuse is just y. The leg length is 8, because we know that, times the square root of 2. So in this case, y is just 8 times the square root of 2. Right? Same idea with this one. It's a right triangle. If he's 45, then he must also be 45, which means the two legs are the same length. So this is the reason why I moved away from letting the leg be x, because in this case, the leg is not x, the hypotenuse is x. So if you say that the leg is x, and then they let the leg be a variable other than x, then, we would rather look at how the side lengths relate to one another. So in this case, y is the same as 25, right? And we know that the hypotenuse, if we wanted to do this again, we can say that the hypotenuse is the leg length times square root of 2. So the hypotenuse being x, the leg length being 25, times square root of 2 is what x is. So not much going on here so far. But we're kind of justifying some of the ideas here. So let's try one more. Okay. So we know it's a 45, 45, 90 triangle, right? We know that the two legs are both x and y. So whatever x is, y will be the same as that, but we don't know either of them. Now again, we know that the hypotenuse is equal to the leg length times square root of 2. In this case, the hypotenuse is 19. Since both of these are legs, I'll just pick x. So we know that the hypotenuse, which is 19, is equal to the leg length, which is x, times square root of 2. Now we have this equation that we can use to solve for x. So we can undo the multiplication of the square root of 2 by dividing. So technically, x is equal to 19 over the square root of 2, but we want to rationalize the denominator. It's never simplified considering a fraction with a root in the bottom. So if we rationalize the denominator, right, multiply the top and the bottom by square root of 2, then this would give us 19 square roots of 2. Square root of 2 times square root of 2 is square root of 4, which is 2, right? That's the whole reason we multiplied by square root of 2. And we have no root in the denominator. 19 over 2 does not reduce, and we can't reduce roots and non-roots. So this is as simplified as this is going to get, right? We rationalize the denominator, so we can say 19 square roots of 2 over 2, and we said that x and y are both the leg lengths, so both of these would be 19 square roots of 2 over 2, right? So, let's look at the other one. All right, the other special right triangle, which is a 30, 60, 90. Okay, so again, to start off, we're going to try to justify what the side lengths are in comparison to one another. This one's going to be a little bit more tricky to justify, but it shouldn't be too bad, right? So we'll justify why these relationships are the way they are. So if I have this triangle, let's say I reflected this triangle over this line right here, right? This leg over here. So he would look like this, right? So if I reflected him, since this is a 60-degree angle, that means that this guy would also be 60 degrees. Right, if this guy is 30, that means he must also be 30, right? I'm going to let this side right here be x, length x. That means he is also length x because I reflected. Now, instead of thinking about this as two separated triangles, if we think of this as one big triangle, if this angle and this angle are 60, and 30 plus 30 makes 60, then this is an equilateral triangle. All the angles are 60. So this leg, or length of this triangle here, is going to be 2x lengths, so he's going to be 2x, which means all three sides are all length 2x, because it's equilateral, right? In terms of the original 30, 60, 90 triangle, the only thing that we don't know here is this leg I'll call A because he's a leg length, right? But since it is a right triangle, we can use Pythagorean theorem to relate these three sides together, right? So far we've justified that the short leg, which is the side that's across from the 30-degree angle, right? Smaller angle creates smaller length. right? So I'm going to let the short leg be x. That means the hypotenuse, the one across from the right angle, is 2x, right? It's the long leg that we haven't justified yet. But we're getting there because we know that we can use Pythagorean theorem to relate this. So we can say a squared plus b squared, which in this case is x squared, equals c squared, but c is 2x, right? So a squared, x squared, if I square 2x, which is like 2x times 2x, that's going to give me 4x squared. But I want to know what a is. So if I subtract x squared from both sides, I know a squared is equal to 3x squared. And I can square root both sides again. And just like before, the square root on the x squared is going to cancel to leave us with just x. And then the square root of 3 is the only thing left underneath the root. So this long leg, the side that's across from the 60-degree angle, so bigger angle makes bigger side, smaller angle makes smaller side. So he's going to be a ratio also of the short leg, x square root of 3. So again, instead of using x's, which becomes kind of hard to manipulate when they start moving the x around, we're going to think of this as two different things here. We can say that the hypotenuse, in this case, is equal to 2 times x, which is the short leg. So the hypotenuse is twice as long as the short leg, right? And the long leg is also in terms of x, so we can say that the long side is equal to the short side, which is x, times square root of 3. So we've removed the idea of x being in here and replaced it with the short side. So the short side really moves us along because we're labeling the short side as x, and then the long side is the short side times square root of 3, and the hypotenuse is 2 times that of the short side. So these are going to be much more helpful when we work these down. Now, let's take a look at some of these. Okay. So I recognize that it's a 30, 60, 90 triangle, right? So what I'm going to do is I'm going to label the sides. I want to know which one's the short side, which one's the long side, because I want to make these relationships in terms of an equation. So the length across from the 30-degree angle is the short side. The one across from the right angle is the hypotenuse. And this guy would be 60, so across from 60 would be the long side. So now I can see the relationships that are supposed to work, right? I know that the hypotenuse is twice the length of the short side, right? So if the hypotenuse is twice the length of the short side, then the hypotenuse, which is x, is 2 times the short side 14, which is 28, right? And we know that the long side is the short side times square root of 3. So the long side y is equal to the short side, 14 square root of 3. I can't multiply roots and non-roots together, so this is just going to be 14 square root of 3, right? So, another one, I can see that it's a 30, 60, 90 triangle. Across from the 30 degree is the short side, which means this is the long side, and the one across from the right angle is the hypotenuse. So here we know that the hypotenuse is 2 times the short side. So the hypotenuse, 32, is equal to 2 times the short side, x. Short side is x. So if I wanted to get x, I can divide by 2, right? So 32 divided by 2 is 16. And we know that the long side is the short side times the square root of 3. So I can just take my short side, multiply it by square root of 3 to get the long side. So we're always looking for the short side in a 30, 60, 90 triangle first. If we can get the short side, then we can build the other two sides if necessary. If we don't have the short side, we're always going to find it first because both relationships of these two other sides are with respect to the short side. Let's try another one. So again, I see that it's a 30, 60, 90 triangle. So across from the 30-degree angle is my short side. Across from the right angle is my hypotenuse, and he's my long side. So I have my long side. Long side is equal to the short side times square root of 3. The long side is 9 root 3. The short side is x, and root 3 is just a constant in this equation. So to get x by itself, I can multiply root 3 cancels with division by root 3. So these cancel, they'll leave me with just x. Now, root 3 again divided by root 3 cancels as well. So in this case, x is 9, which is the short side, right? And we know that the hypotenuse is twice as long as the short side. So if I just multiply my short side by 2, I'll get my hypotenuse, which in this case is 18. Right? So if this is a 60-degree angle, obviously this is a 30-degree. So again, 30, 60, 90. Across from the 60-degree is my long side. Across from the 30-degree is my short side, which means he's my hypotenuse. So again, I know that the long side is equal to the short side times square root of 3. And then I can fill in the values. The long side is 20. The short side in this case is y. I can remove square root of 3 by dividing again. Right? But again, I need to rationalize my denominator here. So if I multiply top and bottom of this fraction by square root of 3, these will cancel to leave us with just 3, because 3 times 3 is 9. Square root of 9 is 3. And then we have a 20 root 3 on the top, which can't reduce. Now, we can't reduce roots and non-roots. Remember, 3 doesn't go into 20 evenly, so we can actually just leave this as 20 root 3 over 3. Right? And since the hypotenuse is twice the length of the short side, if I just multiply this by 2, which is the same as 2 over 1, then I can put the 20 and the 2 together, so this would just be 40 root 3 over 3. Right? Okay. So now that we've looked at these, I mean, that is everything. So now is just, I've just took the time to mix these up, and that way we can kind of go back and forth, make sure we remember the relationships between the sides, and don't really forget, which one we're looking at. Okay? So, as we move through these, you can easily just pause the video, and see if you're getting them right. Until you get the hang of it, I would suggest writing out the relationships, right? So in this case, we recognize that it's a 45, 45, 90, which means the two legs are the same length. We have the hypotenuse. We know that the hypotenuse is equal to the leg times square root of 2. So again, I'm just going to write the relationship, put the values in, and this is going to help move the equation along to get the values that I'm looking for. So in this case, the hypotenuse is 28. Both of the legs are x or y. I'm just going to pick x times square root of 2. So if we divide to get x by itself, we know that x is equal to 28 over the square root of 2, but we want to rationalize the denominator again. So this is going to be 28 root 2 over 2, but 28 over 2 in this case can reduce. So 2 goes into 28 14 times. So in this case, x is just 14 square root of 2. And since both of these are legs, we know that they're both 14 square root of 2. Right? So I got a right triangle, 60 degrees. So this is a 30, 60, 90. Across from the 60 is my long side. Across from my right angle is my hypotenuse. And across from the 30 is my short side. So I'm labeling the 30, 60, 90. I don't need to label the 45, 45. This helps to make sure I'm putting these together correctly. So x is the short side. We know that the short side is half the length of the hypotenuse. So if we divide the hypotenuse by 2, that's going to give us our short side, right? Which in this case is 19. And then we know that the long side is the short side times square root of 3. So not much going on here. The short side times square root of 3 is just 19 square root of 3. And there we have it, right? All right. So 30, 60, 90. Across from the 30 is my short side. Across from the right angle is the hypotenuse. Across from 60 is my long side. So I know that the long side is the short side times square root of 3. Right? My long side in this case is 15 root 3. My short side is x. And we can get x by itself by dividing by square root of 3, which in this case cancels. We don't have to rationalize. So 15 is x, right? Now the hypotenuse is twice the length of the short side. So if we multiply the short side by 2, 15 by 2 is 30. Right? All right, 45, 45, 90. We're actually given a leg. We know the legs are the same. So that means x must be 4. And the hypotenuse is the leg times square root of 2. So 4 times square root of 2. We actually knew the pertinent information right from the beginning. So we were able to kind of just move that one along right away, right? All right, let's try to step this up a little bit here. So we got like 2 triangles like merged together. That's all right. We're just going to keep track of what's what here. Okay? So in this triangle, I don't know much. I know that it's a 30, 60, 90 triangle. So if I wanted to label these, this guy would be the long side. This 30-degree angle would create my short side, and this side would be my hypotenuse. But I don't actually know any of the sides, so I can't really do anything here, right? In this triangle, it's a 45, 45, 90, which is fine. We know that the 2 legs are the same. And we know one of the legs already is 35. So if this leg is, 32. Since this leg is 32, then that means this leg must also be 32. And if this leg is 32, then the hypotenuse, right, is the leg times square root of 2. So x in this case is the leg, 32, times square root of 2, right? Now that we have this side, though, we can get into this triangle. Because we know that the hypotenuse is twice the length of the short side. So if the hypotenuse is twice the length of the short side, and the hypotenuse is 32, and the short side is z, then we can divide by 2 to get z, right? 32 divided by 2 is 16. And then we know that the short side times square root of 3 is the long side, so the short side times square root of 3 gets us that long side, 16 root 3. Right? Okay, so again here, I mean, even if I picked a triangle, right, I don't have much going on here, but in this triangle I do. I do have a side length. I can use that. So since this is 30, the side across is my short side. That means this guy's the long side, and this guy is the hypotenuse, right? So, if the hypotenuse is equal to 2 times the short side, and the hypotenuse is 12, and the short side is x, then x must be 12 divided by 2 is 6, right? And we know that the long side because I need this guy to get into this triangle. So if I know that my short side is 6, that means my long side must be short side times square root of 3. Now that's not y or z, but I do want to put them here because now I can see what's going on in this 45, 45, 90 triangle. If these two are legs, then that means y is the same as 6 square root of 3 because my legs are the same. And then I know that the hypotenuse is equal to the leg times square root of 2. So the hypotenuse z is equal to the leg, which we said was 6 root 3, times root 2. That's just part of the relationship here. But I can actually multiply roots together. Square root of 3 times square root of 2 is square root of 6. So z is 6, because I still got this guy, times square root of 6. Right? So, again, we got a 30, 60, 90 triangle. I know that this guy makes my long side, right? This has got to be my 30-degree angle, which makes my short side. So he's got to be the hypotenuse. The only problem is I don't know anything about this triangle yet. I know that these two sides are the same because they're 45, 45, 90. So I know that my hypotenuse is equal to my leg times square root of 2. So the hypotenuse in this case is 15 square root of 2. The leg is z times square root of 2, right? So if we divide by square root of 2, get z by itself, the 15 is all that's left because the root 2's will cancel on both sides. So in this case, z is 15, right? Now, if z is 15, then that means that this side must also be 15. So the long leg of this left triangle is 15. So how do I relate my long side? We know that the long side is equal to the short side times square root of 3. So since the long side is 15, and the short side is y, and square root of 3 is just itself, we can divide by square roots of 3, right? But we don't want square root of 3 on the bottom, so we're going to rationalize. So this is going to be 15 square roots of 3, right? Square root of 3 times square root of 3, square root of 9, which is 3, but 3 divides into 15. So 3 goes into 15 5 times, so y is 5 square roots of 3. So since y is my short side, if we double the short side, we get the hypotenuse. So if we double the short side, which is 5 square roots of 3, that is our hypotenuse. So I can multiply the 5 and the 2 together. I can't multiply roots and non-roots. So this is just going to be 5 times 2 is 10 square roots of 3. Right? All right, one more. So I got my side down here. This is a 30, 60, 90 triangle. I'm going to go ahead and label them. Z must be my short side. This guy is our hypotenuse. And this guy across from the 60 is the long side. So again, long side equals the short side times square root of 3. That's a 3. So the long side is 18. The short side is z times square root of 3. So if we divide by square root of 3, we need to rationalize. So 18 root 3 over 3, but 3 goes into 18, what, 6 times? Remember, this is z, so z is 6 square roots of 3. Now that's the short side. So the hypotenuse is 2 times that of the short side. So 2 times the short side is 12 square roots of 3, right? Which I'm just going to put that right here. Well, I'll put it right here. Now, in a 45, 45, 90, x and y are going to be the same, and we need to relate that to its hypotenuse. So the hypotenuse is the leg times square root of 2. In this case, the hypotenuse is 12 square root of 3. The leg, I'll just pick one, is x, right? If I divide, this gives me x on its own, but I need to rationalize, right? So if I multiply top and bottom by square roots of 2, the 2's will cancel, right? I'll just come this way. So I can multiply these roots together. So I got my 12. Root 2 times root 3 is root 6. Root 2 times root 2 is root 4, which is 2. But then the 12 over the 2 reduces down to 6 root 6. But since x and y are both legs, that means y must also be 6 root 6. Right. So, thinking back over this, right? Recognizing the type of triangle that we have, 30, 60, 90, 45, 45, 90, right? Thinking about the relationship between the sides should help move you along here. We state what the long side is, state what the short side is, and then we have this tangible equation to solve for. Instead of trying to think about the relationship of the sides in your head and then try to do a lot of the movement in your head, that might be a lot of moving parts. So just a quick refresher of the relationships and then giving you something tangible to work with should help kind of make this a streamlined process here. Okay?